This is section 7.4, equations with rational expressions and graphs. And I know you're upset, but we're not going to be doing the graphing part. Okay, what we're going to be dealing with are fraction-like things. What's different about solving these equations, and notice there's an equal sign here, that's what makes these different from what we've been doing in the previous sections, is what makes this different from the other fraction equations we've solved is that we have variables in the denominator. Our approach is going to be the same as they were with regular fractions. We're going to multiply everything by the least common denominator and then solve. The difference is, now that we have variables in the denominator, you may remember from 7.1 where we talked about the domain and finding the numbers that must be excluded. It is possible, even likely, that we will get false solutions through this process. We will have to double check every single potential answer that we get to make sure that it doesn't give us a 0 in the denominator. Okay, so we have to do at least a partial check on every one of these problems. Okay, so let's look at 6 over 5x minus 2 over 3x equals negative 8 over 45. Now, I know from looking at these two that just at these two, my LCD would be 15x. Let's see, is 45 divisible by 15? Yeah, so I can use my LCD is going to be 45x because the x's cancel out here. 5 divides evenly into 45. 3 divides evenly into 45, and we have the x. 45 divides evenly into 45. This is my LCD. So I'm going to multiply everything by that. So I have 45x over 1 times 6 over 5x minus 45x over 1 times 2 over 3x is equal to 45x over 1 times negative 8 over 45. Now, all of our denominators should cancel out. Those x's cancel. 5 goes into 45 9 times. 9 times 6 is 54. Minus. Here, our x's cancel out. 3 divides into 45. It goes in 15 times. So 15 times 2 is 30, and this is equal to, the 45's cancel, so we have negative 8x. Okay, 54 minus 30 is 24, is equal to negative 8x. Divide both sides by a negative 8, and I get negative 3 equals x. Now, at this point, this is just a potential solution. We need to take this value and look at every denominator and see if it ever gives me a 0. 5 times negative 3 is negative 15. That's good. 3 times negative 3 is negative 9. That's good. There's no x here. So this is our answer. It was a good answer. No false answer here. Okay. Let's try this one. 3 over k plus 2 minus 2 over k squared minus 4 is equal to 1 over k minus 2. We need to find the LCD, so we can multiply everything by that. So we want to look at these and factor everything. Well, k plus 2 does not factor. Put it in parentheses. K squared minus 4, this is a difference of squares. It factors as k plus 2, k minus 2. And then k minus 2 does not factor. So for my LCD, I need a k plus 2. I have the k plus 2 written. I need a k minus 2. And I have a k minus 2 already written. None of these are raised to exponents other than 1, so this is my LCD. So I need to multiply each of these three things by this. Okay, you will probably get to where you do not have to write out this step. It can be very tedious, but until you do, go ahead and write them out. Avoid your mistakes. And when I rewrite this, I'm writing it in factored form. one more to multiply. 1 over k minus 2 in parentheses. Okay, so we should have a bunch of cancellations. Here the k plus 2's cancel. So I have 3 times k minus 2. K plus 2's cancel, k minus 2 cancel, so I just have a minus 2 here. And that equals, the k minus 2's cancel out, and we have 1 times k plus 2. And just for the pattern, I'm going to write the 1 in. It doesn't numerically matter. Okay, just so you have the pattern of whatever was here, you'd be multiplying it by this. All right, let's distribute. That's going to be 3k minus 6 minus 2 is equal to k plus 2. Combine the like terms here. I have 3k minus 8 is equal to k plus 2. Okay, so I need to subtract a k from both sides. So that's 2k minus 8 is equal to 2. Add 8 to the other side. 2k is equal to 10. Divide both sides by a 2, and we get k is equal to 5. All right, potential answer, we need to double check. If I take a 5 and I plug it in here, I get a 7. Plug it in here, I get a 3. Both of those are good. And here, you'd have 25 minus 4, which is 21, which is not 0. So this is a good answer. Okay, so let's do 6 over x minus 4, which does not factor, plus 5 over x, and x is simple already, minus 20 over x squared minus 4x. I can factor an x out of this to get x minus 4. And you can see that your LCD is going to be x times x minus 4. Okay, so if I do x times x minus 4 over 1 times 6 over x minus 4 plus x times x minus 4 over 1 times 5 over x is equal to x times x minus 4 over 1 times negative 20 over x times x minus 4. Here our x minus 4's cancel, here our x's cancel, and here they both cancel. So I have 6x plus 5 times x minus 4 is equal to negative 20. Okay, let's distribute here. I have 6x plus 5x minus 20 is equal to negative 20. Combine like terms here. 11x minus 20 is equal to negative 20. If we add 20 to both sides, they cancel out and we get a 0. So I have 11x equals 0. Divide both sides by an 11, and you get x equals 0. Now, you can potentially get 0 as an answer. This is not automatically a bad answer, okay? If I took the 0 and I plug it in here, I get a negative 4, and that's okay. But if I plug it in here or here, it gives me a 0 in the denominator. So this was a false solution. You don't really want to scratch it out so you can't see it. You want to be able to come back and view your work in case you made a mistake. Now, it's possible that you get 2 answers to one of these because you have a quadratic and you end up getting 2 possible answers. It's possible for one to work and not the other. But in this case, this was our only potential answer. It gave us a 0 in the denominator, so we had to throw it out. And since this was our only possibility, this thing has no solution. Okay? There is no number you can plug in here that will make this equation work, because the only potential answer we had was a 0 and it had to be thrown away.